or option question 3C, second question. Define radius of convergence of a power series. Find it for the power series summation n is 1 to infinity x minus 1 raised to n upon n raised to 3 into 3 raised to n. तो ये सब में हमें क्या करना है, पहले हमें रेडियस ऑफ कन्वर्जेंस ऑफ अ पावर सीरीज की डेफिनेशन लिखनी है. ओके, एंड देन फाइंड इट फॉर द पावर सीरीज. मतलब कि हमें रेडियस ऑफ कन्वर्जेंस आर ये पावर सीरीज के लिए फाइंड करना है. तो ये सब में हमें सिर्फ आर ही फाइंड करना है. ओके, हमें यहाँ पे इंटरवल ऑफ कन्वर्जेंस फाइंड नहीं करना है. सो नाउ फर्स्ट डिफाइन radius of convergence of a power series. A positive number r is called the radius of convergence of the power series summation an x minus c raised to n if the series converges for mod x minus c less than r and diverges for mod x minus c greater than r. So this is the definition of radius of convergence of a power series. Now let's discuss how to find R for this series. Now this one is given series. Okay, find the radius of convergence R for this series. Now first of all, this one is a power series. Okay, so what is the general form of the power series? General form of power series is summation n is 1 to infinity x minus c raised to n into an. Okay, now compare with this series. So what is my c? Here c equal to 1. Okay, and x minus c raised to n, the remaining term is what? An. So here an is what? An is 1 upon n raised to 3 into 3 raised to n. Okay, so this is the power series. Now to check the convergence of the power series or to find R, what we use? We use ratio test. Okay, so what is the ratio test? Here find L. L is equal to limit n tends to infinity absolute of an plus 1 upon an. Now see here, this an is not this an. Okay, this an is the coefficient of x minus c, but in ratio test this an is what? The entire nth number of term. Okay, so now if this limiting value is less than 1, then the series is what? Convergent series. If this L is greater than 1, then the series is what? Divergent series. Okay, so now here we are interested to find radius of convergence R. Okay, so that's why what we use this condition, because this gives the condition for convergence. Okay, so now let's apply ratio test. For this test, what we need? an and an plus 1. So here, what is an? An is equal to this entire term. Okay, nth number of term of the series. So an is x minus 1 raised to n upon n raised to 3 into 3 raised to n. And what is an plus 1? An plus 1 is n plus 1th number of term. And how to get? So in an term, n is replaced by what? N plus 1. So here everywhere n is replaced by n. So an plus 1 is x minus 1 raised to n plus 1 upon n plus 1 raised to 3 into 3 raised to n plus 1. Okay, so an and an plus we have. Okay, so next evaluate this limit. So L is equal to limit n tends to infinity mod an plus 1 upon an. So this one is nothing but limit n tends to infinity. Now put this value an plus 1. So an plus 1 is what? X minus 1 raised to n plus 1 upon n plus 1 raised to 3 into 3 raised to n plus 1. Now entire upon an term. So an term is what? X minus 1 raised to n upon n raised to 3 into 3 raised to n. Okay. So this is my L. Now simplify this. Limit n tends to infinity. Now in absolute, this one is x minus 1 raised to n into x minus 1. Okay. In denominator what we have? N plus 1 raised to 3 into 3 raised to n into 3. Okay. Now shift this term in numerator. So what we have? This term transfer in numerator and this term in denominator. So we have n raised to 3, 3 raised to n upon x minus 1 raised to n. Okay. So now this term is cancelled out. Again this 3 raised to n, 3 raised to n is cancelled out. So after simplification, what we have? We have limit n tends to infinity. Here mod x minus 1 mod n raised to 3 upon 3 into n plus 1 raised to 3. Okay. Now again simplify this. Now this value is free from n, so take common x minus 1. Again 3 is constant, so take outside. Limit n tends to infinity n raised to 3. Now in denominator n plus 1 raised to 3 is given. Okay. From this take n common. So when we take n common, it's not simply n. This is n raised to 3. Okay. So n raised to 3 is common. 1 plus 1 upon n raised to 3. Now this term is cancelled out. Apply limit n tends to infinity. So this value becomes 0 and entire value become what? 1. Okay. So what is the answer? L is equal to mod x minus 1 less than 3. Okay. Now, but before what we discuss, as per the ratio test, for convergence what we need? This one is less than 1. Say yes or no. Because we are interested in radius of convergence. Okay. So that's why now simplify this. Mod x minus 1 is less than 3. Okay. So as per the definition, this one is what? My radius of convergence R. So R is what? 3. Because here what we have? This one is nothing but what? Mod x minus c less than R. Okay. Refer the definition. So this is my radius of convergence R. This is the entire solution of this sum. You can refer. Okay.